This is our third video on stacks, and the first was introduction. The second video talked about using arrays to implement stacks. And this third video, we're going to talk about implementing a stack using a linked list. So as always, the linked list has the advantage of not having to decide in advance how many nodes that you're going to have. So that's really the biggest advantage of that. Okay. So So we're going to go through and show how we could use a stack. So the basic idea of the stack, again, being more memory efficient, is that when we add a new element to the stack, we're just going to, in essence, add at the head. Okay, so we're going to add from head and remove from head. Okay, shouldn't have to do anything else special for that. So the code should be relatively straightforward. And we'll go through some codes here in a minute. But first, we have a picture here. So I want to create a stack, and we're going to use a stack top variable like we did before, but this time it's going to be a pointer to a node or a node type. Okay, so when we push the first time through, okay, we're going to check, is it an empty list? If it is, we're going to go ahead and create, I guess actually we're going to create a new node first. Okay, so stack top would point to nothing to begin with. So let me get rid of that guy. Okay, and then new node is what would point to this guy here. Always forget to change that. Okay, got to change to that arrow. There we go. And the new node would have a 6. And the new node would have I can't get where I want to get. Yeah, the backslash. Okay, that's the first node. Okay. So I would then look at that and the stack top, since there's no existing stack top, would now point here. Okay, so I can move this guy up to here, and I can make the stack top point to that one. Okay, so that's our first element. When we go to push another node, okay, we're going to drag over in my rough little drawing here. No, that's not what I want to do. Why are we doing that? I don't know. There we go. I'm going to create a new node here. We're going to point new node to that new node. Okay. We're going to set up this one. Oh, okay, this one would have a 10. This one would have a backslash. Okay. And then as we've done before with linked lists, okay, we want to tie in the stack top to this new node. Okay, that'll be the new head node. Okay. To do that, move things around here a little bit, I think would be helpful. We're going to take this link of the new node to make sure that we don't forget or don't lose the rest of it. And I'm going to point this up to where stack top points currently. Okay. I can then move stack top over to this new node. Okay. I don't need the new node anymore. Okay. So now we have the 10 being the new top. Okay. And then in the same way, if we were to add, move all of this over a little bit. Okay, I'm going to grab one more new node here. This is not the most efficient way to do things, but I don't have a board, so you do what you do. So we're going to create our new node for our last one. Okay, so that new node is going to contain a 2 up here, and it's going to contain a backslash there, as always. Okay. Now this backslash, we have to make sure we're going to reroute it to where stack top points to. Okay. So it's going to go up to this node. Okay. We're then going to, and that's not in the right place. That should be down there. Should go to up there. There we go. Now we got the pointer straight. Okay. So now we're going to have stack top. Put this guy up. I can never get a hold of him. To here. And now stack top will point to this item. Okay. And this should have moved. Don't know why it didn't. Okay. There we go. So stack top now points to this first guy. Make this look a little better up here. There we go. Yeah, so we now have our stack. Okay. So we've just inserted at head, basically. Okay. So then we want to pop something off. We're going to first, for example, well, not for example, but if we wanted to get to top, the top is going to be stack top info. Okay. That's going to be where the top's at. If we want to pop something off, we just have to let stack top be equal to stack top link. That'll point it over to there. And then this one would go away. Okay. So that's the idea of how it's going to look. So now let's take a look at what the code would look like. Okay, so from the book, I have copied over the basic information here on setting this up. Okay, so this is going to, again, use the stack ADT. The stack ADT is going to set up all of the functionality of the functions of the stack. Okay, so I'm including that over here. Okay, so in order to use a linked list, I'm going to have to create my node type here. Okay, then I'm going to have my, and again, it has info and it has the link, which is a pointer to a node type. Okay, we then have our template class type, the class linked stack type, okay, that inherits from the public stack ADT. Okay. And then we have our different functions here. The first we have is the overloaded assignment operator. Okay. We then have the is empty. We have the is full. We have the initialize stack. We have the push, which takes a new item. We have the top, which returns that item. We have the pop, which removes the first item. Okay. In addition, we have the default constructor. We have a copy constructor, and we have a destructor. Okay. As far as what we're holding, the private data, okay, we're going to have this node type pointer called stack top. And then we're going to, just like in the other instance where we were using arrays, we're going to have this copy stack, which is a private function that gets used by the assignment operator and the copy constructor. Okay. So let's go ahead and type in some of the main functions here, just so we can get a feel for what's going on. Okay. So we're always going to have our template class. We're going to call it type to be consistent with the book. You can name it whatever you want. Okay. You have to put that before each one. And you'll type that a million times and wonder why you are, but that's just how it works. Okay. So if we call this one linked stack type, again, it's templated by type. Okay. And this is going to be the linked stack type constructor. Okay. So when we start off, all we have to do is set the stack top equal to the null pointer. Okay. Not much going on there. Okay. So let's look at the is empty and is full. I'm going to go ahead and copy this over. So I'm going to type it a million times. So that will stick around, but it probably won't. Okay. So this is our Boolean function. And remember, when we're doing the namespace, we have to put the return type first. So this is linked stack type. So our namespace is empty stack. It's a constant because whatever we're sending to whatever we're checking, the list we're checking shouldn't change. That's why that constant's there. Okay. So all I have to do is return the results of is stack top equal to the null pointer. If it is, true. If not, we're false. Okay. So again, template class type, another Boolean function. It's the namespace is the linked stack type. This is the is full stack. Okay, it's also a constant. This one's the easiest one you're ever going to write because no matter what, it's going to return false. Okay, because we're using a linked list, it can't be full. Okay. So next we have to think about how we're going to initialize the stack. Okay. So again, we have our template. All this code's in the book, by the way. I'm going through and explaining it as we go. Okay. So we're going to have our template class type as always. This is a void function, okay, for our initialized stack. So it's the linked stack type. Initialize stack. Okay. So we have to think when we initialize the stack, what are we going to do here? Okay, so we're going to start with a node type pointer called temp. Okay. We're going to use that to delete any nodes that happen to be in the stack. Okay. Because we're initializing it. This is not the constructor. You have a list that you want to wipe it out. Okay. Then we're going to say while stack top is not equal to the null pointer. Okay. So while there is still something in the stack. Okay. We're going to let temp be equal to the stack top. So we can capture that. We're going to let stack top be equal to stack top link, which will move us to the next item that in essence deletes the first item or removes the first item from the list. Okay. Once we've done that, we can delete the temp and recover that memory. Okay. That should be the initialize. So let's take a look at the push. Again, the push is going to be like the add to head in the other stuff that we've done. Okay. So we have our template class type again. This is a void function for the push. We have the linked stack type. It's the namespace we're in. This is the push function. It's going to take a constant because what we're adding in, we're not going to change. So the new element does not change. The list changes, but the new element does not. Okay, so note I don't put a constant here because the list is going to change. Okay, so then I'm going to create my new node. So my node type, but it's now typed. We didn't have to do that before. We didn't have the typed ones. Okay, new node. It's going to be a pointer to the new node. Once we have that, we have to actually allocate the memory for the new node. Okay, so we're using the new keyword there. Node type. Okay, that creates the node. Once we've creating it, we can set the new node info equal to whatever the new element that we've sent into the function. Okay. And then because we're adding at the top, we can set the new node, and we know we always add at the top. The new node link is going to be equal to stack top, just like I did in the diagram a second ago. Okay. I can then set stack top be equal to this new node. Okay. And I have, in essence, added a new element at the head of the list. Okay. So we've also got here the top function, which is going to return that element, that first element. Okay. We have our class type as always. You'll type that 1,000 times. This is going to return a type. Okay. So it's whatever the element in the linked list is going to be, or the stack is going to be. Like stack type. Top function. It's a constant function, and it does not change the stack at all. Okay. So we're going to do an assert here. We're going to assert that stack top is not empty, so not equal to the null pointer. We could also use our is empty function if we wanted. Okay. We're then going to return stack top info. Okay. So since I've used the assert, I have to go back up to the very top. And I have to include CAssert library. Okay. So again, the way the assert works, if it's empty, and long term in a program, I'm not sure you would want this, because this won't give you an error. It probably should. This is just going to stop the program and give you an assert error. Probably not the best way to go. Okay. But yeah, that will get the job done for now. Okay. And then the last one, I think, is going to be the pop. Okay. So the pop basically is going to remove the top item from the list. Okay. So as before, we have our template class type. Okay. We have a void. It's a void function, doesn't return anything. Our namespace in here, link stack type. Okay. This is the pop. Pop takes no parameters. Okay. And it's not constant because it is going to change things. So again, I have to create a temp node type pointer because we're going to be deleting things. So let's call this temp. It's a pointer to a node type called temp. Okay. And then I've got if stack top is equal to the null pointer. So I'm going to see if it's empty. Okay. No, sorry, if it's not empty. So basically there's something left here. What I'm saying here. And then let temp be equal to the stack top. Okay. That's capture that information. Then like before, I'm going to let the stack top be equal to the stack top link. It's going to follow its link to the next item of the link list. Okay. I can then delete the temp. Okay. And that's all in the if. We've got an else here. So rather than using the CAssert and just throwing them out, we're going to actually capture this and say that we cannot move from an empty list. Empty stack. It's a list, but we're using it to model a stack. Okay. Okay. And those are the basic parts of this program, right? The book also has a copy stack function. We have the copy constructors, the destructor, where we're going to basically the destructor, all it does is to call the initialized stack. Okay. And also we have the overloading of the assignment operator. Okay. And that's gonna do it for the most part. Okay. So there's a little test program there as well that once you type this in, you want to go ahead and run the test program to make sure that it's working. Okay. Um, so the other thing that we could do here, which the book talks about, which I won't go into detail, but you should look at, is that you could, if you try to derive stack from the class unordered list, okay, that's certainly something to think about here. So the push function is just the insert first function that we talked about before. Okay. So that would make some sense. So things do line up to some degree. Okay. So we can derive the class linked stack type from the class unordered linked list type. Okay. And the book shows you a way to do that. Okay. So one of the advantages to that is that you have the code, mostly done, which is a good thing. The disadvantage, I think, and the reason we didn't do it first and didn't do it as a bigger example, is that it gets away from the use of the stack ADT. And I think it's useful to have the stack um, the stack ADT set up to define the functionality. Okay. And when you would use when you derive from the unordered linked list, the other disadvantage is that um, it's it's not as natural and it doesn't look as much like the one that we do with the array. So I think that's really the reason we wouldn't do that. Okay. So the last section on the stack part talks about uh, applications of stacks. Okay. The first example being the postfix expressions calculator. Okay. So the postfix expression arithmetic is also called reverse Polish notation. And the way that it works, for example, and you can read this in the book, if we would have A plus B plus C, which we would normally do that expression. Okay. The way it works in this postfix expression form would be A, B, C plus. Okay. So that kind of shows there's on page 1216, there's examples of the infix and the postfix way of doing things. Okay. So it gives an example here of how we can use a stack to push those things onto the stack. Okay. In fact, there's some code where it's actually going to set that up for you. Okay, which is interesting, and you should look through that. Okay. So that's one of the many uses we have of stacks. Okay. And there's also, and we've talked about this before, using a recursive algorithm to print a list backwards. Okay. And there's a section here on doing that, printing a list backwards in a non-recursive manner. Okay. And that will finish us up with stacks. Okay. So the next video will be on implementing queues with arrays. And it turns out that is not as straightforward as stacks are. Okay. And then the last video will be on queues being implemented with linked list. And it's pretty basic as well. Okay. So make sure you're reading the book as well. I think it's important to help in the understanding and go through the examples in the book. Someone had asked a while back, they were taking a math class. And they're like, how can I better prepare for class? And one of the math professors gave an answer, which I thought was really good. They said basically work through the example problems on your own and make sure you understand how those work. If you understand how the example programs work, then you're going to understand how to move forward with your own problems. Okay. So next video will be on to queues.